Hello, my name is Saeid Sheikhi. I'm a doctoral researcher at the Center of Ubiquitous Computing. My research focuses on the cybersecurity and creating the various solutions for securing the different platforms, including the cyber physical system, industrial systems, IoT devices, and emerging networks like a 5G and 6G. Now I'm presenting one of my research called NextGen Defense, AI-enhanced real-time anomaly detection with the superior explanation and interpretations. It's working on using the AI methods for real-time anomaly detection with using the also generative AI for explanation and interpretations of the explanations in the anomaly detection platforms. So first, we're giving a background of the evolutions of the cybersecurity defense systems. As we can see, our cybersecurity defense system evolved in response of the complexity of our network. Before 1995, we had relatively simple network alerts as a defense system in order to alert the system for intrusion attacks. But late 90s and the early 2000s, after we have a home network and internet, we had new systems like antivirus and the new tools like a firewall and IDS has been developed in response of those development in the network. In the later, when we had like a internet and cloud, we have a new tools like IDS, IPS, and there's like a DLP and the CM has been developed in the response for those evolutions of the network security, network systems. In the future, as we can see, when we have like a 6G and metaverse with the 50 billion devices connected to our network, we have facing the new challenges in the cybersecurity. Those challenges need a new security framework, new security defense framework to facing those challenges and overcome those issues. Now we are looking at the phases of this study that have been developing the cybersecurity solution for the future, that when we need a new and comprehensive solution for the cybersecurity issues in the near future. So our research have four phases. First, we are starting with creating the cyber range. We're developing a new cyber range that has a different real-world network and different components that we can also creating and testing our security solutions on them, simulate the attacks and collect the data. We're simulating the different attacks on the networks, such as the DDoS, man-in-the-middle attack, and the different attacks that are specifically are for the 5G or the different systems. We deploy the models into like a production mode and using it and testing it and see that how it's reacting to the different situations. And finally, we test and analyze the results to improving the model and refining it and improve the detections of that and efficiency. So the cyber range. Now we have developed the different cyber range. It has a different layers of the network, including the cloud layer, fog layer, cellular network, and edge layer. In the cloud layer, we have a multiple GPU system, including like a Kubernetes. It's used for the training of the AI models, deploying the LLM models, and sometimes also using for training of the LLM and fine-tuning the LLM models on that. In the fog layer, we have a Synology that is a disk that we are collecting and storing our network data over there, and the virtual server and the switches. In the CLR network, we have a 5G core. RAN, radio access network, is included there. Finally, in the edge layer, we have a wireless router, virtualized hosts, and IoT devices. And in this layer, we have ensuring that all of the IoT devices, some of them connected to the wireless router and some other connected to the 5G, and they are sending their information and we collecting those information for our need and testing the devices. So in the 5G cyber range structure, we have different 5G, different systems, and we can see that we have 5G core system and RAN. We have different UE, user equipments, and this, as you can see, we have a 4 user equipment and 1 Kali node. The Kali node has been used for simulating attacks and using as a malicious node for our network. And then all of our network data are passing through the GPRS tunneling protocol, or called GTP. We are using this protocol for collecting information and collecting our network packets, and then later using it for creating a data set and training or creating the intrusion detection system. Simulated attacks. We have a different attacks that's simulated in our 5G or other systems, and one of them is the DDoS attacks. It's very common attacks that has been used for overwhelms the network with excessive traffic. And then we have like a man-in-the-middle attack, intercepting the communications between the devices in the 5G, between the slice. And across the slice, exploit vulnerabilities between the different networks slices, allowing the attackers try to attacking and accessing to the different slice while he has not allowed to access to those slice. And PFCP, like a PFCP protocol, to manipulate like a packet forwarding, and it could be kind of the DDoS, but it's attacking to the user plane part of the 5G core. In creating our solution for cybersecurity system, like creating our intrusion detection system, we need to choose the correct learning methods for our ML IDS. For our model, we are having a few options called supervised learning, unsupervised learning, and semi-supervised. In the supervised learning, at the first, we requires the label data. Each input has a corresponding output. This part is very important for us because in the network security, we have limited annotated data. We have a model that can work without using too many labeled data. For the second one, we have unsupervised learning. Unsupervised learning does not require the labeled data, completely opposite to the supervised learning that needs the labeled data for doing the decision. And we can using the unsupervised learning for detecting the cyber anomalies in the network without using the labeled data for training of our model. And there is a semi-supervised learning that combines labeled and unlabeled data and provide a model that can work in the detection of the attacks on the network. But each one of them has a different use cases. We are more focused on the unsupervised learning and the supervised learning. For our IDS, sometimes we are using the unsupervised, and sometimes for our needs, we're using the supervised version. And then for the like a future-proof solution, we should have like a different architecture also. We're using the federated learning architecture for our cybersecurity solution. It has some benefits. For example, privacy preserving. It keeps the data decentralized, ensuring the sensitive informations are in the local. Scalability, we can running that and expanding that between the million of the devices. Enhance the security. It's reducing risk of the data breaches because all of the sensitive information stay in the local. Edge efficiency, deploying those models on the edge devices and then testing them in the real environment because it doesn't need to have a high computational power for training of the models. Next, we can see the architecture of our 5G federated learning model for evaluation. That, as you can see in here, as I said in the previous slide, we have 4 user equipment and one Kali Linux node, which is a malicious one, and it's all connected to the 5G core. We have 2 networks. Each network have one IDS, and all of them are connected to the global model, which is on the cloud. In the cloud, the global model aggregates the weights that it's received from these smaller models that are in the H5G core and aggregates those weights and sending back to the model. Imagine like there is an attack, like a PFCP attacks on network 1, and the network 2 never saw those attacks. But because all of those models aggregate weights, later the network 1 sharing the attacks with the network 2 based off this federated learning mode, and the network 2 can be detecting those attacks without have been seen them before. Next, now we can see the IDS system workflow. It's a structure of our IDS and how it's working. We're collecting the network traffic, using the span port and then sending them to the ML pipeline that is in the ML flow and is inside of the or Kubernetes system. It will be used for model training. All of the models will get training, and then also all of them get versioned, and the different version and updated version going to be over the older version. And then it gives an API that you can using it for the prediction of the new records and also getting the explainability of those items. All of those information will be storing into the Elasticsearch. Elasticsearch will be connected also to our dashboard system that we have is a modern dashboard that will be showing us the different metrics of how well our IDS is performed. In the next slide, we can see that dashboard is network incidents and threat monitoring. We can having the different informations like how many records and how many packets that we had, how many incidents it happens, which protocols, and our productions and consumptions, because we're using some agent for transferring our network traffics into the flow, into our cloud system. In that case, we can see how well our production and our consumption is. So how well we are transferring the data and how well we are consuming those data. So we then checking that we are not missing any packets and not missing any incidents that happens in our network. And we can also making some actions to prevent major network disruptions. In the next, we have explainability for AI model. The part of this dashboard, when you are having some incidents, you can searching for incidents and getting the more informations about that. Then when you go into the details, you see the such page in our dashboard. There is a different threat details and explainability. It has a SHAP force plot, SHAP model explainability, and future values, future importance, and it giving some insights about what was the decision and why the model has been done this decision. Because if you are not an expert user, after you see those plots, you have no idea what's happened, why the model has been made such decision, and why this record is an anomaly record. So this platform shows you some information why model has done this decision, why this packet has been classified as an anomaly. And later you can be using it for improving your model or making some other, adding your training data, improving your model, or making the other actions. In the next here also we have another chatbot. It has a tool section. It's in the same page with the explainability model and the explainability data. And you can having interpreting the model decision by using the LLM model. We use the LLM device to getting the better informations of and interpreting the explainability data that we had in the previous page. So a non-expert user after saw those plots, and then he can using this chatbot and this part of our platform to getting some information, generate some information, and interpret those plots in the system. And also this chatbot is an interactive chatbot, so you can, talking with the AI model, getting some advice about the situation of your system, and getting some advice like what response you want to make to improving the security of your system and the other situation. We are also going to making it actionable, so later you can be using this chatbot to improving your response. Like you can asking it to giving you advice to you some options for response to this detection. And then after it's giving you some response, some suggestions, you can choosing one of those suggestions and asking the model to applying those response to your defense system. Like it could be a wazoo, or it could be your firewall to blocking an IP, or some other actions that can keeping the resilience of your network security. And as I said, it's very helpful for the non-expert user to get a better insight and better understanding of these informations and doing the proper actions based off that. So our next steps and the future directions. We are going to be using expanding the model variety. We are going to using the different models, including the large language model, LLM models, and for the intrusion detection system. And then we are going to using the real-world 5G devices. And as we know, having some real-world 5G devices are connected to our system, but we simulating some other devices like IoT devices and other 5G devices that are connected to our cyber range. So we are in the future going to be using the new 5G devices and adding some 5G routers and phones and other systems. We enhancing the attack simulations, simulating the more complex and diverse cyber attacks, such as the advanced persistent threats like APT groups. They are very high level of the attackers. We are going to simulating the different tactics and the techniques that they have and try to detecting them using the or new model like LLM models or the new versions of the or cybersecurity defense system, and refine interpretability. And we're going to improving your interpretability to have a better information and explain better what was those plots and what was the decision of the model made by and different situations after our cybersecurity incident, and optimize the performance at the edge. We are going to optimizing our model to it get able to use in the edge, and we can deploying it on the models on the edge devices and in the edge, like different small devices that they don't have much computational power, so they can loading our models and using it without getting any interruptions in their other duties that they have. Okay, thank you. That was my presentation of my work, and thank you for listening to me.